Before I start, you're supposed to have this on your desk, and these are gifts, mostly from Taiwan. On my right hand side, this is pineapple biscuit. It's a very famous dessert in Taiwan. And there are two pieces inside you can try. And the other is not eatable. It is a microcontroller. So don't try to take a bite. And I will explain what it can do later in my lecture. So, and I have more in my hand. If you are really interested in, you can ask for more. And in this lecture, I'm going to talk about the fundamentals for AI. So there is a little bit math, but not too much. And the most important thing is that we are going to train a machine vision model now in this room. Because yesterday a gentleman probably you asked me like how to access for like big GPU with big memory. So I changed my slide last time. Okay, let's see what we can do. And I will talk about large language models again. So this basic idea will let you know like what you can do with these models, what is possible and what is not possible. And before that, let's talk about the digital images. So what are digital images? So say this is a gray label image, and if we enlarge this patch, you'll see, okay, different labels of gray labels. So, and they are numbers between 0 to 255. Okay, and for color one, if we enlarge them, for each pixel, there are three numbers: a red, a green, a blue. So, what are images to computer? Those are numbers, right? Okay, so remember this, keep this in mind, because computers, they really don't think from my perspective. They only do calculation. So when you provide a computer an image, that means you provide a computer a bunch of numbers. And they will do the calculation from those numbers. And let's see what machine vision can do. They are 5 tasks. As I said, the first is classification. So it tells you what image it is. This is me on your right-hand side, and this is my humanoid stand. That's a gift from my student on Teacher's Day. And I asked them, why do you give me this gift? They said, if I am not there, they can take photos with it. So I'm wondering if it is for them or for me, you know. And the second is localization and classification, also called object detection. So we detect object inside the image and then classify what kind of object it is. And second and fourth are segmentation. But one is segment like from the foreground and background, only two class, and the other segments individual person in this image. So imagine this is a plant or some a vegetable that you want to separate it from the background. This is called segmentation. And for the fifth and sixth, those are for animals. One is video classification, the input is video. And sixth is object tracking. So these are the basic, the 6 things that machine vision can do nowadays. So I would like to explain the background of machine vision from the very, very beginning. The most small unit of a neural network is called a neuron. It's similar to our brain. You know, it's a neuron cell. One neuron cell takes input from other neuron. Those inputs are called eggs. Eggs 1, 2, 3, 4 different eggs. And it does some process and then render an output because why? Okay, then humans try to mimic this process. So we develop one model like this. Okay, so for each model, each neuron, we have output Y over here. And there's one weight for each input. We have W1, X1, plus W2, X2. And also there's a term called bias, or we call it intercept. Does this equation look familiar to you? Like high school linear algebra. Do you do like this y is equal to ax plus b? Do you solve this equation?
Yeah.
We are giving xy to solve ab, or we are giving ab to solve xy? Which one?
Right.
We are giving xy, right? So for this equation, we are giving x, a bunch of x and y, and we are solving w. Okay, we are solving w. And that's basically the idea of a neuron. And we put neurons together, many neurons. It's going to be called a neural network. Okay, so imagine what parameters that we have to set for neural network. Like numbers of neurons in one layer, or like how many layers you want to in one neuron. These parameters are called hyperparameters. They are determined by human hyperparameters. But the W's here, you can see many W's that you have to learn from data. Those are through training. Those are parameters the AI learns from data. Okay, if this neural network is trained, that means if these W are determined, and we can use this trained neural network to do this, let me erase, okay, to do classification. That means you have a bunch of data. Remember, X is what? Is an image. It is a bunch of numbers, right? And then we feed this X into our neural network. This is called a artificial neural network. And then we determine what class it is, and this is Y. So this is the basic idea of neural network. Very simple, so simple. But it's oversimplified in the sense that it is not accurate anymore. ANN is very famous, when I was a college student, maybe between 1990 to 2000. Okay, then after that, it started to grow because the accuracy stops. It doesn't increase so much. And later on, there are many other ways to connect neurons are invented. What do I mean, like many other ways to connect neurons? So for image, do we say for each pixel, this is one pixel. The pixels are neighborhoods, right? We have this is hummingbird, the big ear over there, and the big is a shape like this. So the big are like red, the pixels are connected to each other. These are called spatial information. Okay, and in order to take the advantage of the spatial information, there's one structure, NN structure, invented called convolution. Have you heard of convolutional neural network, CNN? So this is the idea. So it takes advantage of the pixels. Pixels are x, x1 to x9, and we times x1 to w1. W1 is the weight you are going to train, and plus x2, w2, h2, till w9, x9, and we sum them together as y. And this is convolution. So convolution is nothing special. It is just this simple. Okay, and there are many NN structures invented, and all of them are worth mentioned, but this is going to be a long, long lecture, and all of you will fall asleep very soon. So I don't mention too many of them, just one, transformer. Have you heard of transformer?
Yes.
GPT, that T is transformer. Okay, it was, well, I would say not invented, but become famous in 2017. Nowadays it's 2024, right? Remember, like these neural kind of things, they evolve slowly, like the human beings, like our civilization. Okay, so we will recall this date, years later in the lecture. So one CNN is actually a complicated network that composed of many convolutional layers. This is a very famous CNN called AlexNet. Take a guess why it is called AlexNet. Because the inventor is called Alex, right? So maybe one day you invent some, very powerful things, and it is named after you, okay? So they are 5 evolutional layers here. And as I said, we put X in and we get Y, okay? And for every neural network, there are 2 phases. One is training and the other is inference, okay? In the training, we provide X and Y, and what we want to get is W, right? We want the weight. We want weight. And after the weight are trained, and they are determined, then if we have X and the trend W, then we have Y. That is so simple. Now take a guess. Which phase takes more computational power? The training or the inference?
Training.
Training, of course. And we are going to train a CNN very soon. So consider it is accessible to every single of you here in this room. Online, on cloud server. We'll do it later. Now, before doing that, I would like to take you guys take a look like the development and size of these neural networks. Now, the circle size represent their number of parameters. The LXNet is over here. Okay. Now, take a look at the size. The parameter number is approximately 65 millions. Okay. And millions are mapped to mega in computer, right? So, but this is not only 65 mega, because one parameter can be 4 bytes. So, 65 times 4, sorry, I'm bad at math. 260, right? Mega bytes. Okay. How big is your GPU memory? How big?
1 giga, if it's, the standard one giga perhaps?
The smallest one, like say 1080 Ti, that could be like 8 gigabytes. Can it fit this model? Absolutely no problem. Okay, for training, absolutely no problem. Now let's see the axis. This axis means the operation. So size of the neural network is not, positively correlated to the operation, or let's say computation. And this is the accuracy. So we want to find the model at which corner? Here, 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 or there. Which corner we want? We want to have the smallest operation, while the accuracy is the highest, right? So those models are good models. So maybe you have heard of these, like GoogleNet, ResNet, Inception. Those are very common convolutional neural networks. Okay. On the other side, these kind of CNN are for classification, and the other ones are for object detection. The most famous one, YOLO. All right, how big they are? Now let's say YOLO B, this is what, 7, 9, B9, 56 millions. Okay, say, let's call it 60 millions. Okay, the size are very, very, not that big. Okay, I would say small actually, compared with like what you have in your computer. Your RAM is much bigger than 60 mega, right? Like for your computer. Usually it's 2 gigabytes of RAM or 8 gigabytes. If you are familiar with computer, I'm not sure how familiar you are with computers. And let's make it even simpler. No, well, we have to make it simple. Otherwise, we cannot train it today. So thinking about there are 60 millions of parameters in one neural network. So how many lines do we need to write a program for a neural network? Will be large if we don't have libraries. Okay, we would like to take advantage of libraries that are free and they are provided to us, and they will do debugging for us if there's any issues with their library. Those are called frameworks. And the most famous libraries are PyTorch, or Keras, or TensorFlow. And some fast libraries are conveyed too, because this is C++ based. They are fast. And these are Python based. Okay, Python based. They are slower, but they are very neat. In a sense, LXNet, I just said 65 millions. Like how many lines? Take a guess. I'll give you another free set of microcontroller. Take a guess. How many lines do you?
Three, perhaps?
Three? Three is too less. I mean, yeah, 65 millions of parameters. But it's not too many.
10 perhaps?
10?
3,000.
3,000? No. 40.
Okay.
40 lines. Isn't that simple? Right? Simple enough. Okay, so this is what we are going to do. This is what we are going to do next. So before I try to teach you how to train a neural network, I would like to introduce one data set called NIST. It's a very famous handwritten figures. We have from 0 to 9, only 10 classes. Okay, and it is available online. Okay, so we don't have to pre-process the data. Actually, in deep learning, training is not a problem. The pre-processing is the problem. Okay, and here are the 6 steps to train the model. The first is actually process the data and put them into feature matrix. And then we have to separate data into training and test. And third, then we have to define a model. But these models actually are online available. You can download them from GitHub or many other web pages. Then we define those functions, we train and test. Some are too far, so I don't want to talk too much about that. So let's do it now. If you have a computer and if you receive my Python code, then please follow me. Have you received this Python code CNN? Do you have this?
Yes.
Okay, if you have this, please stay with me. Okay. All right. So the most famous, let me start from here. Okay. The most famous and free cloud service is Colab. It's offered by Google. So let's type Colab. Okay, then search for it. Welcome to Colab. Okay, then we click this. Okay, this is free to everyone. As long as you have a Gmail account, you can register for one, and then you log in like this. All right, and what do? We upload the file that I just provided yesterday. So let's go to the desktop over here. It's called CNN. IPNYB, that means Jupyter Notebook-based Python code. It's a little bit complicated, so just ignore and feel that you can train a deep learning model. Then that's the point, okay? So first we have to check that we are using a GPU. So let's check this. We are connecting. Okay, and we will feel the powerfulness of GPU. And okay, it gives us a T4. What is a T4? Tesla 4. And let's see the memory later. Okay, the first thing we have to do is to import libraries. Okay, remember I mentioned something about the library or the framework for training a deep learning model. What they are? The most famous one, PyTorch, TensorFlow, right? Do you see torch here? Do you see torch here? That is PyTorch. That is PyTorch. All right, so first thing is that we load all the libraries over here, okay, and then we can use these libraries. And second is we want to check the size of memory available to us on that graphic card, Tesla. So here we have Tesla T4 over here. And what's the size of the memory? Okay, to take a look. Over here. 16 gigabytes. Now you have a 16 gigabytes GPU for free, as long as you log in. Okay, all right. And no one is using that one. It belongs to you solely. Okay. Now let's do the data set load. Okay. This is going to load the data set online, and so it takes some time because the data set actually is downloaded from some other web pages. So is anyone following me? Are you with me?
Okay.
Anyone with any question, or you are doing fine?
So we run the first one, then
So we run one by one. Yeah.
There's an error in number 7.
What?
I have an error in step 7.
7.
Yeah. The problem is with the device variable. Perhaps it's not defined in any part of the code. Device is when you are calling the CNN and you are putting it into a device. So the
Right.
device in the step 7, as she was saying. Step 7, because you are in step 2.
Yeah.
So I'm in step 1. Do you like jump? You have to do one by one.
Yeah.
You
One
take-
is okay.
I'm having the same things.
Okay. Let's see. So if we like plot the data set we load are numbers. Remember, images are numbers and function numbers over there. If we plot the number, we can get this figure. Okay. All right. And next is that we want to define parameters, and these are parameters that we can determine. And the next is to prepare the data. We have to split them into training and test. Okay, the training is to train the model, but we don't test the model using the training data. It's like you are a sport player and you are also the judge. That is unfair, right? Okay, so we split the data into training and test. And next is that we arrange their Y. That means the output is 0 to 9. Then we define some number. This is a little bit complicated, but I don't want to go through this. But this is the model that I'm talking about. This is one very simple CNN. Okay, how many lines do we have? 10, 20. Not for this one. This is less, way less than 40. Okay, this is probably let me see. 1, 2, 3, 4, 5, 6. 6 layers CNN. One line represents one layer. Just so simple, okay? And then we define, we put the model. What's going on?
That's the error I was talking about.
Oh, okay.
Yeah, it's not defined in the device. But I mean, and it's suggesting that we need to define the.
I don't see device here, no. Do I make any? Oh, device is here. So how do I send this to you, or you want to type?
yeah, everything.
Device is equal to torch dot device and parentheses cooldown. Okay, this is the line tells you that this is the GPU that you want to use it to train. Okay, please type because this is not so.
I put it in on WhatsApp.
Okay, cool.
So then in the group, the WhatsApp group, you can copy the line and it will be before the line of the model.
Yeah.
I don't know.
And WhatsApp.
In WhatsApp. Yeah, WhatsApp. Yeah.
Después de
Before we train the model, we have to provide which GPU device we want. So we need that line. Let me see. Over here. All right, now define the device. The device is CUDA. Okay, CUDA means the GPU, the NVIDIA GPU core. It's called CUDA. Just these two lines will solve that issue. All right, it lets you find the device. Has everyone catch it up? or need more time? No?
Yes.
Yeah, well,
Okay, something you just still working on it, yeah. Okay, and after this is to train the model. Now remember, I said epoch is equal to 3. That means we train the model using all the data for 3 times. Why do I do so less? Because it takes a lot of time to do the training. It takes maybe 1 or 2 minutes to do the training, and you'll see that the circle is like rounding. Okay, really takes some time, and you can do like 10 efforts or 100 efforts. And this is the speed of a GPU. If for a CPU, it takes 100 times more. Okay, so you have to wait for a week if you want to train a model, and then it's really crazy. And this is the powerfulness of GPU. And while I'm still talking, it's still doing the training. Okay, now the 3 efforts are down. You can see the training loss in the very bottom, like this. Okay, and actually we want to plot that the training loss. So what is training loss? Basically, it's error. We want the error to be smaller. Okay, so we want to see that in each effort is going down and further down. If you train it more, say 100 efforts, you'll see that it's going down very quickly, slowly, not quickly. But basically, it takes a lot of time to do 100 efforts. And the very last step is to test the model. And the test model is to use the test data. And here we can see that overall accuracy is 98%. So just a 7-layer CNN can achieve an accuracy of 98 for hand return figures, okay? Now imagine, like, maybe you don't have GPU, but you have access to Google Colab, right? So what can prevent you from training a deep learning model? Since today you can go home and train your own model. All right? Any question for this session? Are you all with me? Like, no?
No.
I will try to help you later.
I keep on having error.
Yeah, I just have a question. I have the same final number, but in the middle of the test, my number vary a little bit. Doesn't matter?
For everyone, they're supposed to be different.
Oh.
Because when we train the model, the parameters are randomly initialized. So like during training, we all have different results. If they are the same, there must be something wrong, all right? Must be the machine is cheating, Google is cheating. Yeah.
But the real coding is the file that you share with us. Real code.
What do you mean real code?
The program.
The programmer, yeah, they do these kind of things. Just that it depends on like how complicated your input is. Like usually for this
Type of image.
this image is 28 by 28, so it's not large. But for nowadays images, they can be 640 by 640, pretty large, right? So it takes it occupies a lot of GPU's RAM space. And so it's nothing to do with the programming, but like the equipment you have, or for Colab, if you idle for say 5 minutes, it will kick you out, stop you from training your model. So you have to pay that. Otherwise, you have to keep shaking your mouse or doing things like that. I have a student who write a Python program that shakes the mouse automatically. So you can do that too. I mean, we have ways to deal with that. Any other question? By far? Okay. Hopefully you enjoy your very first CNN model. Okay, let me go back to my slides. So, what we train is a classifier. Okay, classifier is you have an image and you have a CNN that is a classifier and you have a single output Y. Then how do we do object detection? So for each object in an image, what parameters we will need? We need their coordinate, right? Their locations. So say for this dog, this is a corgi, I believe, very cute. X, Y is this holder. And we have width and width height. And we have also a class that is a dog. So a total of 5 outputs. A total of 5 outputs. Let's just, increase the number of outputs. It's nothing fancy, nothing magic. So it is so straightforward. Okay? For segmentation, it is pixel-wise for each pixel. It determines the pixels class. Okay, so the output is pixel-wise. Output is pixel-wise. So deep learning is about what? All about computation. It is nothing magic. It is nothing magic. Okay, let's go to another topic. No, now let's come back to the generative AI. So I mentioned discriminant AI, and actually many of you train your first CNN model, a discriminant AI. For the generative AI, I say that the definition is that output is automatically managed, right? The number. So how big are the models? How big are the models? So I mentioned about this before, so let's take a look at the GPT. GPT-1 was released in 2018. The parameters numbers is 117 millions. Is it big? Not really. It is as small as maybe twice of a YOLO. All right. In the next year, 2019, GPT-2 was released. The parameters 1.5 billion. What is the difference between millions and billions? Millions is 10 to the 6, billions is 10 to the 9. It's getting bigger, right? Now, in 2020, the model size is 175 billion. And for GPT-4, it is not officially released. There's no information. It's a black box. But some scientists say it's 1.7 trillion. 10 to the 12. Now, can you fit this model in your computer? No, not really. Can we train it? Not really. There's no way. They are too big. For GPT-3, how much data do we use to train it? 753 gigabytes. I will use an analogy. That means you read Harry Potter, the book set, for 10,000 times. 10,000 times, okay. And how long does it take for you to read? I mean, our reading speeds are different. I'm a slow reader, so it may take me 200 years to read it, yeah. And for my kids, they are reading fast. But it really takes a lot of data to do the training. And this is called pre-trained model. And is there any model that is similar to GPT-4? Of course, there are so many, like Ernie, Gemini, Cloud, Olympus. Those are very big models. And there are also small models you can see in the bottom here. We have some small models too. So I mentioned one application that is intelligent farmer service. And I also mentioned that we don't want ChatGPT to answer the question for us. We want to use the reports written by the researcher from the Agricultural Research Institute in your countries. Because in your countries, the data, the reports are specifically for the case in your countries. So those are the best answers. So how do we do that? How should we start? Like if we want to train a large language model, there are 3 steps. First is pre-train. Second is fine-tune. And third is reinforce. Now, imagine you want to train a ChatGPT. Is it feasible? Not really. It's so big. And fine-tune, what is fine-tune? Fine-tune is that you use some good quality data. So remember for the pre-trained model, the data doesn't have good quality. They are not checked. There might be some text from internet, all right? From Wall Street Journal. If you heard that they actually sue ChatGPT for using their data to train the ChatGPT-4. So fine-tuning is a set of like question and answer, good quality data, or full length text and abstract, or say Chinese and English for the translation. Very high quality data. All right. And the third step, reinforcement learning. What does it do? Actually, if you use ChatGPT last year or the year before last year, there's a thumb up or thumb down option that you do. That is reinforcement learning. They use real human to train the model for them. That is smart, right? That you use the model for free, but actually you are doing the job for free for them. Okay? So where should we start? There are open source large language models. Lemma 3 is actually released already a few months ago. And here the B means billions. Those are the parameter sizes. Okay? And on the left-hand side, those are called the animal set. Lemma, Vicuna, Falcon. On the right-hand side, MPT, Bloom, and Mistral. Okay, small, large language model. They can be as small as 7 billion. Can you fit a model of 7 billion in your computer? Billion makes to mega. It's 7 billion, right? We times 4, that is 28 not mega, gigabytes. It is possible. It is possible. So this is why we call like the AI PC. So we can actually put an AI in the PC. All right? But training is another thing. Training and inference are way different. Training takes this, a data center that was donated to UF, not to NTU. So endless, okay? Since we don't have it, I guess you don't have it, it's impossible to do this. So our best bet is retrieval augmented generation. So the idea is that when farmer asks a question, we have a question. All right, we use another model to convert the question to a code that's called embedding model. And then we use the code to do the search. And the search document is high quality document from your countries. And then after we find some document that has high similarity with the question. So these are full-length documents. And then we put them back with the question together to the large language model. And the large language model will do comprehension, find the answer, and will do abstract, or say, shorten the full-length document and find the key answers and answer the problem. And this is called RAP. It's actually not one single approach, it's a set of different approaches. It's very complicated. And for the large language model, you might want to use the model that is fine-tuned with your language. You don't want to use Lemma. Lemma is tuned, fine-tuned using English, not your language. Like in Taiwan, we use Tiger and Breeze. Those are the best traditional Chinese language models. Okay, so this is the reg versus fine-tune. So what is reg? It does search, right? There's a search engine. So it's open book examination. So you have book sets that you can find the answer, and then you can look at the answer and write down answer. All right. And fine-tune is closed book examination. You have to memorize everything. Like I worked overnight last night to prepare these slides. Right? I don't want to do that anymore. Okay. So this is probably the last class for me in Florida. Yeah. So that's not there yet. Let's take a look between the reg and fine-tune. How does ChatGPT behave using reg and fine-tune? Actually, ChatGPT is not fine-tune. Let's go to ChatGPT 4 and let's select the most powerful model for all. Okay, it's paid basically. If you are rich, you are powerful. Okay, let's ask a question. What are the pesticides for treating strawberry and nose, if I spell it correctly. Okay. It answers you very quick, all right? And it tells you how to use. But the name is, some farmers, they use a very common name, not this scientific name. So it's going to be a problem. And it also doesn't tell you the specific way to use this pesticide. But if you find a web page or document, actually, this is a document from UC Davis. It's about strawberry and drug. Okay, and it tells you the exact usage, the dose for the pesticide over here. Okay, and we can utilize it. What I did is that I download this as a PDF. It's over here. Oops, sorry. This is just the same material, but it's stored in the PDF. And I upload it to ChatGPT. All right, and create a strawberry body. Okay, it's a reg service. It's a reg service. If you want to know how, I'll tell you later. And when I ask questions, well, tells you exactly how to use the pesticide and tells you the dose over here. Not really. How? Maybe sometimes it's not so smart.
It's also, yeah.
Oh, so it's giving details in the parentheses besides the name, right?
Yeah.
So that's something that you will not get from the previous one.
Oh, maybe, yeah, but
Yeah, switch 62.5 WG, I don't know what it means.
no. If it is strawberry body is actually a reg service that I create. Using the OO as the base, but the document as for search. Yeah. So here I have to choose strawberry body.
Yeah.
Yeah.
Ah, okay.
Let me try it again. Because it worked last night, but not sure. Oh, it works this time? I'm not sure why. Yeah. It tells you the exact instruction, like how to dilute. So it is question dependent. All right? It is question dependent. Yeah. So that's one problem we have to overcome anyway. So this is about large language models. So do we have any question for this session? We do not define?
No. So what would be the first step to start training some model for maybe our company, for example, Because we have some technical documentation about the product, so we can do that here?
Yes.
You did with
You can
Discovery,
do it with
but-
ChatGPT.
Oh.
Yeah, it's the most easy way, but they will charge you by tokens. Like every time you upload, you download, that means input and output tokens, and that means money. Yeah. And token is a very vague idea. Like for one English word, that could be like 3 or 4 tokens. Yeah. Yeah, they break down that like retrieval, is 1 token, tree is 1 token, ball is, AL is 1 token, yeah. I'm not sure about your language, but that's how it works on English.
Yeah, and Spanish is a pretty expensive one because it's trickier. It's long sentences, different ways of saying the same thing, those extra problems you have there. So it would be a bit more expensive.
Yeah.
Yeah, privacy.
Privacy.
That's one of the projects that actually we're trying to do this once. I already did this, what you did. For some documents, of course, they are free, but then we are concerned of using internal documents, so I can load up there in the database. So I don't know in that sense what will be the solution. They say I review the API, so I'm doing through the API. They say that through the API you have privacy and you have all these standards for security and not leaking data, but I'm still,
Well, yeah.
I'm still concerned.
They can steal your data if they want.
Yeah.
Yeah. If you upload it, they want it. It really depends. And so this is what I propose, a local RAG solution. You only need a small, large language model. It's a little bit complicated.
But should be in our language. I didn't know that part because we are trying that with a team of development in software.
Yeah.
So they already did RAG. They tested a small model, but the model is not doing pretty well. But I didn't pay attention to that thing. So I will tell to my team that actually let's look for a model which is in Spanish. Thank you so much for that advice. I
No problem. Yeah. All right, let's move to the language. I promised this is the language session. So this is about the microcontroller that I bring you. It's called Arduino. So if you open this box up, you can see that in the very middle there's a board wrapped with plastic bag. That's a microcontroller. And with that microcontroller, you can do many things. Maybe not so powerful. Let me play the game over here. If you hook it up with a soil sensor, this is a soil sensor that I didn't provide. And there's a relay that can drive a motor that you can do many things. It's too unfortunate I don't have time to teach you how to use Arduino, but there are many resources available online. And for the soil sensor, if you need that, email me and I will send it to you overseas. There's no charge. Yeah. Okay. Or talk to the general secretary of ICDF. They will send you 1,000. Yeah. From you. All right. And see, this is what we use Arduino in school. I teach college students. And as a man, I cannot resist to high-speed vehicles. So we do this a lot in school. So basically, and again, I have to thank to my students for preparing the slides and the teaching material. And I know my job is a professor, but I do irrigation too, not only engineering. I irrigate people with latte, coffee latte. So if you have a chance to come to Taiwan, and basically, of course, you are more than welcome to have a cup of coffee latte. Thank you very much.
Questions?
About coffee latte? Thank you very much.